Function composition is something that is very important for pre-calculus and ridiculously important in calculus. Think of it as plugging one function into the x's of another function. Sort of like what we saw earlier with our function notation, but we're going to formalize it with a thing. So this little circle here means function composition, and you always want to think backwards with function composition. So what this means is take the g of x and plug it into the x's of the f of x. You always go backwards, right? So we can also think of it, I like it this way better, f of g of x. Do you see how the g of x is plugged where the x goes for the f of x? So take the g of x function and plug it in for all of the x's in the f of x function. Okay, what does this look like when we try to do this using numbers? Okay, so let's look at this equation right here. F of g of 3. What does this mean? It means we're going to take, we always work backwards, take negative 3 and plug it into g of x, and for the x's of g of x. And then we're going to take g of negative 3 and plug that into the x's of f of x. So this means f of g of negative 3. Does this make sense? Okay, so we can come over here and say, well, what is g of negative 3? Remember, here is our f of x, x squared plus 1, and here is our g of x, negative 2x squared plus 5. So g of negative 3, we take out the x's and we plug negative 3 in for those, and we get negative 13. Now, that is what g of negative 3 is. So this right here is negative 13. When you're using composition and when you're figuring these out, you always want to work the inside out. So g of negative 3 was the inside of our function, and we calculated that. Now we're going to put, well, g of negative 3 is negative 13. So we're going to plug that negative 13 into f of x. So what is f of negative 13? Well, that's negative 13 squared plus 1, or 170. So f of g of negative 3 is the same as f of negative 13, which is 170. Let's try it going the other direction. It's not always going to be f of g. Sometimes you're going to have g of f. What does this mean? Plug 4 into f, plug f of 4 into g. So we're going to have g of f of 4. How do we calculate this? You always do the inside function first. So what is f of 4? Well, that's 4 squared plus 1, or 17. Now, what is g of f of 4? Well, that's g of 17. What is g of 17? Well, that's negative 2 times 17 squared plus 5. Ooh, I'm going to have to break out a calculator on this one. Let's pull out our handy dandy Casios here. So we're going to have negative 2 times 17 squared plus 5, and we get negative 573. So that is negative 573. G of f of 4 is negative 573. That's when you're using a number and you're plugging that into the inside function and plugging that into the outside function. Now, let's look at this from a slightly different perspective. Remember, when we had f of g, or f plus g of x, our answer was some sort of equation looking thing, right? Well, just like before, if we have g of f of x, this answer is going to be an equation-y looking thing. It's going to be something like that. Now, notice our f of x's have changed slightly. F of x is x plus 3, and g of x is still negative 2x squared plus 5. Okay, what does g of f of x mean? What does g circle f of x mean? It means take the f of x and plug it into the g of x, right? So think about it this way. This thing right here needs to go into all of the x's of our f of x. That's a little bit crazy looking, but let's see if we can do it. So we're going to start by writing this outside function. And remember, you take out the x's and make them into wholes. And what are we plugging into this? We're plugging in f of x, which is x plus 3. Now, they're not going to want you to leave it like this. They're going to want you to do the algebra and make this worked out. So remember, what does it mean when we're squaring a binomial? You're going to write it twice and multiply. So the -2 is going to be multiplied by the write it twice and multiply bit. So as we multiply these two binomials, we get x squared plus 3x plus 3x plus 9. All of that still needs to get multiplied by -2. And don't forget, we still have this plus 5. So we're going to have -2x squared minus 6x minus 6x minus 18 plus 5, and finally collecting like terms. Now there's a couple ways to do this problem, but no matter which way you do it, you should be getting to -2x squared minus 12x minus 13. These do get a little bit more complicated, so let's look at this next problem here. So this time we're taking g of x and plugging it into the x's of f of x. So what is f of g of x? Take the g of x and plug it into the x's of f of x. So what is f of x? And in this case, it's 3x squared minus 13. So 3x squared minus 13. And what are we plugging into that f of x? We're plugging the square root of x minus 6. Now this one is kind of interesting because what do square roots and squareds do? They undo one another. So this squared and the square root undo one another or cancel, and we're left with 3 times just x minus 6, and you need to multiply it by both x and the minus 6. And we still have this minus 13, a little bit of algebra, and this is why you have to go ahead and do the math and make sure that you get these right. So this one is going to be 3x minus 31. All right, my favorite one and the hardest one, and we're not going to do the domain part of this today, but my favorite one and the hardest one is when you get fractions of fractions. These can get a little bit ugly, but it is important that we know how to do this because this kind of stuff will be in calculus. So today we are doing g of f of x. What does that mean? We're going to take our g of x and we're going to plug f of x into it. So it looks like that, g of f of x. So we're going to start by taking the g of x, which is x over x plus 2. And we're going to write this kind of big. So think of it as there's an x here and an x plus 2. Does that make sense? Now, what am I plugging into those places where I put the big circles? Well, I'm plugging f of x, which is 2 over x minus 3. I'm going to change up the colors here to make this a little more clear. So I'm plugging 2 over x minus 3 into each of those places where the x was for g of x. Now, what we have here is a little bit of a mess. It's what I call fractions of fractions, F words of F words, not fun. But when you have fractions of fractions, what I want you to do is look at all of the pieces. So we have a 2 over x minus 3, a 2 over x minus 3, and just a 2. And look at all of those denominators. What's the only denominator that you see? Well, the only denominator I see is x minus 3. So what we're going to do is you can take any fraction, including this big fraction, and as long as you multiply the top and the bottom by the same thing, you're doing something fine. It's just like taking the number fraction 2/3 and multiplying both the top and the bottom by 5 and getting 10/15. Well, 10/15 is mathematically the same as 2/3. So it's just like that with numbers, but we're using variables to do this. Why does this help? Well, if we take this x minus 3 and distribute it into the top of this and distribute it to the 2 and the top of this, it's going to get a little ugly looking for a second, but it's actually going to end up really pretty. So what we end up with is 2 over x minus 3 and a x minus 3 on the top. And then the bottom of our fraction, our big blue fraction, is going to be another 2 over x minus 3, where we have multiplied it by an x minus 3 on the top. And then on the bottom, we still have that big plus 2, which is multiplied by the x minus 3. Now, this looks really gross, but I hope you see what was the whole point of this. The whole point of this is that now in these little red fractions, the x minus 3 on the top and the bottom divide to 1, and so they cancel each other out. So we're left with something that's really kind of not that bad. Like, what's the only thing left on the top here? It's that red 2. On the bottom, we have the red 2 plus the blue 2 times x minus 3. And that's all that's really left. And we can clean this up pretty nicely. So that's 2 over 2 plus 2x minus 6. And we can just collect like terms and make that 2 over 2x minus 4. We could leave it like this. This is a perfectly acceptable answer, but we could also factor a 2 out of the bottom and then reduce. What is 2 divided by 2? That's 1 over x minus 4. Either answer is acceptable. The second one's a little bit better, but either answer is acceptable. Oh, x minus 2. Silly me. When you factor out a 2, that's a minus 2. So either answer, 1 over x minus 2 or 2 over 2x minus 4, is acceptable. The second one's just a little bit more reduced.